Hey everyone, my name is Denis. I'm senior site reliability engineer working on Neuron, the high-impact AI-based data analytics platform at GFK and Nelson IQ. Beyond that, I'm the creator of DevOps podcast on YouTube and Telegram. I'm also lead two exciting projects, ARI, AI Reliability Engineering Framework, and MockMe, the project that connects AI and human intelligence for mock interviews, mentoring, and DevOps assessments. I'm also teach courses on Kubernetes, infrastructure, AIOps, GitOps. So feel free to join me and our DevOps community. Kubernetes controllers are at the head of the automation for the modern cloud-native applications. But how often we think about what's under the hood? Today, let's explore why developing your custom controller is not just the cool project, but it's game changer of your DevOps career. So, agenda for today.
So, why we're here? My goal is to motivate you to start learning and using controllers because I believe that is the best way to improve your level as a software engineer. And this is your confidence on interviews, interesting projects, and good money. How the Kubernetes controllers works. Let's recall the Kubernetes architecture looks under the hood of the controller. We learn the main terms, components, and functionality. Next, I want to share my own experience of implementing a custom controller for the release management system. Let's take a look for a second at my desktop. Yep, as you can see, it was a lot of hard work because of there are many components involved. Clusters, GitOps with Flux controllers, application controller, environments. It can be dedicated cluster dev, QA, stage, internal Kubernetes and custom resources like a Terraform, LLM models of any other that complies with the Open Container Initiative. Some kind of specification, main functionality requirements on top of it, version control, container registry, and API calls. And yep, it was a non-trivial part of experimentation and mistakes. But don't worry, this part has already been explored and the diagram has been refined for the human reading. Okay, let's make this boring stuff more fun by adding some personas. This young lady wants us to stop meeting and start coding. She will be a developer and customer of the release flow. And this guy, he will handle the infrastructure and support the release, just like a SRE. Let's agree right away that we use Git as a single source of everything: code, infrastructure, policy, automation. Whatever is Jenkins, GitOps, progressive delivery, we will rely on version control. In our case, there are three environments: dev, stable, and prod. Usually the situation with the versions here is as follows: something outdated on prod, very good on stable, well, until it's tested on prod, and a complete mess and fun on dev. Developer pipelines build product artifacts in the form of container images that are stored in a container registry. So let's say it's a registry. And our automation point will be GitOps that introduces declarative deployments, automated reconciliation, and in-cluster controllers, fundamentally reshaping how we manage applications. So, easy setup: produced artifacts with the versions promoted through the environments, container registry, and automation with GitOps.
So, many of us have working with the traditional CI/CD approaches, often built on the Jenkins. But today, with the rise of GitOps and Kubernetes native deployments, every developer should have some DevOps knowledge, I guess.
But our story about this guy, next level of abstraction on top of the mentioned setup, custom controller. And I guess it is good time to define some terminology and recap the Kubernetes architecture. A Kubernetes cluster consists of control plane plus a set of worker machines called nodes that run containerized applications. The control plane components make global decisions about the cluster, for example, scheduling, as well as detecting and responding to cluster events. Kube API server. The API server is the front end for the Kubernetes control plane. etcd, highly available key value store used for all cluster data. Kube scheduler, watch for newly created pods with the no assigned node and selects the node for them to run on. Kube control manager runs controller processes. There are many different types of controllers. Some examples: node controller responsible for noticing and responding when the nodes go down. The Cloud Controller Manager lets you link cluster into the cloud provider's API and separates out the components that interact with the cloud platform for components that only interact with your cluster. For example, Flux is a toolset of out-of-box controllers, source controller, customize, Helm, notifications, and image automation. But before, let's learn how the Kubernetes controllers works. Let's start with the big picture. When we define the custom resource, CR, in Kubernetes, we are essentially creating a new object that Kubernetes doesn't natively understand. To make Kubernetes aware of this, we use the custom resource definition, CRD. But defining resources isn't enough. Something needs to actively monitor and reconcile them. That's where controllers come in. At the heart of the Kubernetes controllers is the reconciliation loop. This is where the magic happens. The loop continuously compares the actual state of the cluster with the desired state that makes action if there are drifts. But how does the controller get notified about the changes? The API server acts as a central hub, storing all cluster state information, including CRs and CRDs, in etcd. The controller doesn't pull the API server continuously because of this is inefficient. Instead, it's used the least watch mechanism to get the update only when changes happen. So move the right side of the diagram where you can see the client Go. So this is the Go-based Kubernetes client library. Reflector. This is the component efficiently watched resources from the API server and pushed updates into the work queue. Informer. Instead of directly hitting the API server for every request, the informer watched the Kubernetes resources and cached them locally. Indexer. It speeds up the lookups by organizing caching data in ways that controllers can quickly access. Event handler. When the updates happens, an event handler processes the changes and queue it for the reconciliation. It can be add, delete, update, whatever. Finally, the controller picks up these changes and runs the reconciliation loop, making sure the actual state of the system aligns with the desired state. Flux is a prime example of leveraging custom controllers to implement GitOps principles in Kubernetes. It's built upon the GitOps toolkit, a collection of specialized tools and controllers designed for the continuous delivery. Additionally, Flux offers optional components like image reflector and image automation, which automate image updates by scanning repository and updates configuration accordingly. Also, Flux can be extended with, for example, Terraform or OpenTofu controller and even LLM controller. And by the way, with those controllers, we are working on Framework Days sprints, so you can join. Welcome. Our environment is highly complex, with a dozen of teams managing hundreds of applications. A key component is a Flux image automation, where controllers continuously track each environment for the latest container images in the registry and automatically reconcile the environment state. The challenge became even more interesting when we need to manage a release bundle, a list of services ready to be promoted. This can include business applications, micro frontends, backends, Argo workflows and rollouts, various supporting services, infrastructure components such as jobs or cron jobs or cron bobs, I don't know, and DevOps tools. Additionally, any modern solution should be designed to support AI-driven applications that can be included AI gateway policy, Lang models, and also cutting-edge use cases, for example, CAPI, Cluster API Components. Once the list of applications for the next release is finalized, the next step is to promote it to production. The release team wants clear visibility into the post-release state for each component and application that has been deployed, whether it rocks or completely dead. So, there is a requirement to chatbot-driven interface to manage release and provide real-time notifications after deployment. Of course, solutions should be scalable and maintainable, and this is the pretty much all we need to start the prototyping. And why the code doesn't work or why the code works is a pretty good motto for the prototype, I guess. So the first thing I did was define the communication channel, how we receive commands and where and how we request data. Initially, Slack served as the input interface, while REST calls to the Kubernetes API were used for data retrieval. So the Slack commands were processed and translated into REST API calls to interact with the Kubernetes API. We will also need a channel to communicate with the Cloud API. In this case, it is the Google Cloud Artifact Registry. The first iteration included only synchronized notifications, or rather Slack command confirmation, instead of the actual state. The lag between the comment and actual changes is about 4 minutes due to natural Flux update timeouts. For data processing, we use the built-in in-memory database, SQLite, which is the lightware and fast. At least that is what we are thought at first time. The first controller we are using, it was application CRD controller from the project applications. It helps us to group and define the application's metadata, establish connection points to the infrastructure, enable application level health check, and understanding the related objects in a release. Next, I define the core commands. List retrieves application's version across the environments. Diff generates a list of difference from each application ready to be promoted. And apply promote the changes to the target environment. The process flow begins by retrieving applications from each environment, storing them in an in-memory database, applying filters, generating the output, and responding with the results. In case we apply the diff, additional processing takes place. This may include actions like copying image between the registries and tagging images, such as assign version 101 with a new timestamp. This process is tracked by Flux Image Reflector Controller, which, through the image automation, updates the Helm release configuration in the version control system. This, in turn, triggers reconciliation by the Flux controller, ensuring that the Kubernetes cluster state aligns with the desired configuration. Reconciliation happens, and as a result, each application in the release plan gets the new state, success or fail. So the prototype worked and the POC was completed, but it's so far from the goal. And let's go over the issues and, most important, the benefits to use the controller solution. After the release, we don't know the current state of the environment. We only know that the command has been completed. But even when there are no errors, it doesn't mean that the new version has been successfully deployed. The release manager does not have up-to-date information on the success of the release. Even when, for example, the SRE ran the list command and the system got the state of the cluster again, changes might not have been applied yet, or an error might have occurred during the promotion stage. In this case, involving the SRE engineer will be necessary for troubleshooting. Regarding the in-memory database where we store the current state, if the system is rebooted during the release, we will completely lose the desired state without the possibility of automatic recovery. And one more thing, that on a prototype stage we use the configuration file. It's included some kind of parameters and, most important, SQL request templates that used for data processing and outputs. And it has to be mounted in a pod, as a file on the file system. And all kind of changes should be handled in the code to cover the zero downtime cases, for example, for rotation. So we adopted the fail fast approach. That means that we deployed the prototype directly to the production as a shadow system alongside to the existing one. And this allows us to quickly uncover all the limitations that we previously identified. So additionally, the current release system was a tiny coupling to the Slack messenger, but we started globally migration from the Slack to MS Teams. And at this point, we made the strategic decision, fully transition to the new solution based on the Kubernetes controllers. And I received the green light, to implement the prototype as a main system, and otherwise we faced the risk to become the real senior release managers, because of all kind of releases should be managing manually. And challenge was accepted. I start to develop the custom Kubernetes controller. As we already learned, list and watch the central point to retrieving state of the resources in near real time. HTTP long polling is a mechanism for maintaining a near real-time communication channel between the client and the server. Informers used it for the watch and list API because it's simple, scalable, and compatible with the Kubernetes architecture. One of the biggest technical shifts came when we realized that SQL was not the right fit for our architecture. While this worked, it quickly became the performance bottleneck. The system was not fully Kubernetes native. So this led us to a key decision, moving from the SQL-based storage to an in-memory indexer cache with the APIs and storing persistent state directly in our custom resources that unlock the full potential of Kubernetes controllers. No more static config files. We extended Kubernetes with the custom resources that helps us to configure any controller parameters. With the promotion plan, we can manage release and retrieve the new real-time state for each component during the release and post-release stage. You can find here the Kubernetes API extension with CRDs. New API version, apps, GFK.com, V1, Alpha 1 for kind promotion plan that specify a list of applications ready to be promoted. Promotion plan defines records with the name, namespace, and source images. With the current state new, we just need to drop such object into the cluster, and Informer will trigger the controller to process it, promote the images, get the state, and update this plan with the actual status, errors, etc. The environment custom resource defines the clusters and namespaces as application environments. For each environment, a new informer is created to propagate the cache with the current state. You can use as many custom resources as needed to manage every part of your setup, including role-based access control, default promotion flows from dev to stable and prod, and external integrations like webhooks and notifications. So with this implementation, we got the API for any type of integrations. It can be messengers for chatbots, automation, CLI, scripts, pipelines, notifications, so we can send a message to the Slack, Discord, MS Teams, whatever, or trigger any pipeline job and whatever, and even the platform engineering. I will back to this in 1 minute, but now I would like to show you the result schema of the solution. Imagine this, your team just built a new feature and now you need to ship it. Promote the all related applications safely across the environments, track its progress, and ensure you got the actual state of release. Yes, we can use feature flags, progressive delivery with the flagger, for example, pipelines, or even manually managing promotions, but we have built the API first design, meaning you can integrate it anywhere from platform engineering tools like Backstage or Port to chat ops in Slack, Teams, Discord, and instead of the worrying about deployments, you just push code and watch it on the application level flow, securely, observably, and fully automated. The source code of the project will be accessible as an open source project soon, and the controller build process, creating CRDs, how to testing such solutions with the dedicated control plane of Kubernetes, all this we will cover in workshop format soon. Stay tuned. It works pretty good, but more importantly that we extend it with the API. And it's not only about the CLI and automation capabilities. It's enabled the integration with the platform engineering system, like a port. And we can implement the user interface to observe any changes with our CRs and CRDs. We can fully automate the high level of resource creating, retrieving status, or triggering various actions through the plugins or API. Let me show how the simple integration works. Let's say we have a Kubernetes cluster with the GitOps toolkit installed on it. All components are running in a system flux namespace. Also, cluster already propagated with the CRDs, we can find applications, environments, and promotion plan. The CRDs for the promotion plan uses Open API schema to validate it through and define main properties for Kubernetes object. In this example, we use Port as an internal developer portal solution. The catalog reflects data model and SDLC, We can find our resources already here, and I'm going to show you how to easy we can integrate it. Two data sources defined, one for the cluster objects like workloads and namespaces, and one for the CRDs, environments, promotion plan, and notifications. To integrate with the port, we used CRDs exporters that's running in the cluster. Single exporter for group of APIs. The most interesting thing here that it used controllers and pretty much the same way I described to you 5 minutes ago. This is the Golang application with informers and controller to watch CRDs and export it to the third-party system. So we can define the mapping with the option CRDs to discover to ask controller export matched resources. In this case, I want all resources with the API group apps gfk.com. Let's modify the resource directly and see how it processes the changes. I will change the promotion plan and will set one of the record status to fail. When I try to apply this configuration, the OpenAPI return validation error because the unsupported value. That's how resource validation works. Only predefined values accepted. So let's fix it and apply. Now we can check controller's logs. It detects the changes and export it to the port. We can find it in user interface in audit log. So we can find exact changes in the objects. All system states consist now. Developer portal holds valuable information about organization tech stack, environments, dependencies, applications. Port enables you to use this data to automate workflows and business logic. Automation in a port are triggering by events in our infrastructure, such as a new service created, promotion plan provisioning, or a new application added. This is where the magic of platform engineering seems to begin. But in reality, there is no magic, just Jenkins sitting at the top of the stack. So, as you see, a lot of opportunities we have to develop ourselves or level up our team because of in the topic of the custom controllers, this is the Kubernetes itself, for sure networking, system design, Golang, and whatever. So it's plenty things to learn, practice, and it's valuable. So I guess it was interesting for you, and join me in a social network and see you around. Thank you.
Oh, hi Denise. Thank you for
Hey,
your
hey.
presentation. It was amazing. The blackboard with the stickers was really a unique and engaging way to explain such a complex thing, such a complex context in just an easy way. Just I have a few questions for you, and maybe the first one is more conceptual. What was the main pain which you solved with this migration to controllers?
Yeah, morning everyone. Thank you, Igor. Yeah, you're right about the blackboard or something. Yeah, I tried to find some way, to explain the complex things because of you know a lot, you understand the system and whatever, but explain to another, person, especially in the simple words, it's a real pain, you know. So for the second question about the migration, I guess first it's we need to deep dive in the Kubernetes architecture because of everyday practice with the Kubernetes. It's relied on the well-known things, some kind of operation and whatever. But in case you are deep dive under the hood, uh, you really understand how the Kubernetes interested inside of them. But you catch yourself that some kind of principle you are missing somewhere. Even you have the certificates, for example, administrator of Kubernetes or whatever, you miss the maybe you miss the some kind of a real concept inside of the CRDs, event loop, control loops, controls itself, programming all the things. And it was the first maybe major point to deep dive. And the second one is to make things as a Kubernetes native way, because you can notice that we start like a regular application, database, SQLite, some kind of REST calls and whatever. This is the common steps, but when you play with the Kubernetes, you should actually, work as a native way. So this is the most interesting and most maybe painful points on it. Yeah.
Okay, yeah, just discovering this question more. Maybe when you will recommend this approach in just a regular company, just do you really need to do this in my company or not?
Yeah. Good question. Because of, my my point is now this is the right way to start learning and using the
Mhm.
controllers. Why? Because of, for example, for the trends, for today, I can actually recommend two main trends that you can explore to understand and answer on your question yourself. First, this is the it was the topic from Reddit on KubeCon North America last year, uh, and they shift in all infrastructure to the controllers. This is the very interesting, paradigm shift, because of you have the infrastructure as a code with the Terraform, all the things, but for the organization that rapidly extended, for example, as a Reddit case, they are extended in 1 year from the smaller company to larger corporate, and all kind of techniques, all kind of approach. It's not enough for their case. That's why they shift to the controllers and they close any gaps on the efficient of the work for the teams, as a developers, as a operation team, SREs, and whatever. This is the one case. um, mm, no more details, because of you can find it in the CNCF YouTube channel, and it's really recommended topic. And the second one, this is the maybe the lastest unknown announcement from the Google, AWS, and Azure, Microsoft Azure, about the new paradigm, how to manage the Kubernetes, Project Crow, Kubernetes Resource Orchestrator. So whole gangs, the cloud operators, actually they starting to contribute in a single project. It's some kind of crazy idea maybe, but anyway, it's all around to use the operator with the specially defined this custom resource definition to manage all resources with the infrastructure, application, and whatever on a high level with the single operator. So we can see that time is flows, things is changed, and now, for my point, is the right time to jump in, because of it's already on the on place. So yeah.
Okay, yeah, Nis, thank you for this answer. It's really deep and just interesting. When did you started to migrate to controllers to this approach? And maybe you know how much time do you spend on this migrating from release management to controllers?
Yeah, so previously we have some kind of legacy common way uh, build it application. So it's this is the some kind of custom not trivial with nuances application. That's how it works. And next we starting migrate to the Microsoft Teams as a main point of management of the infrastructure. In this point, I got the task to discover the best maintainable, safe, and extendable way to 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 refine this infrastructure application, so for the whole company. And it was simple. We use the Kubernetes, okay, first one. Next, we use all kind of controllers under the hood, because we use the Flags, all controllers from Flags application and whatever. So this is some kind of native environment push me to use the same way for the control plane. So data plane is a Flags, and control plane, we create the custom controller for all these things. So it was native and very natural way, to start to build controllers. And one more side effect, that's on the interviews, I'm starting to receive the questions about the controller more and more. So I understand that topic on the table now. So that's why.
Okay, thank you. Thank you for your thoughts. And there is one more question from our audience, from Petro. He's asking you: does infrastructure of this solution is fully implemented in cloud, or some part of these are promised? What is the best practice for this, to separate it, or have it on one place?
Thank you, Petro, for the question. The beauty of the controllers, it can be any program in any language. Yeah, for the first place, for sure, it should be Golang and Kubernetes native pattern. But anyway, you can program any of your preference, and you can start it outside the cluster. This is the point. You can just start your controller on your local laptop, and manage the Kubernetes in cloud, on premise, and whatever. So no special infrastructure, because of this is the very straightforward solution. You just start the application that implement the APIs inside of. You just need to authenticate your applications through the clusters, and voila, that's it. So nothing special. You can start for the on-prem, you can start for the custom controllers, or you can use the cloud. In our case, why the cloud here? Because the cloud registry we use in the cloud, we use the Kubernetes in the cloud, and also we use this additional API for gcloud registry as a GAR, so Google Artifact Registry. That's why there is the API calls. But yeah, it's simply as it. Yeah.
Okay, thank you for this. And there is also another question from audience, from Konstantin. If you can tell us how you manage configurations for your applications, and it would be great if you can provide some examples.
Yeah, same. This is the very straightforward approach. We have the Helm. So we have a package. Let's say we have a package. It's called chart. Chart is the base for the application, and we have environments. So when we push when we, let's say, promote the chart to the environments, we have the Flux configuration. So chart, Flux, and environment. So how to manage the configuration? There is some kind of solution inside of the Flux. This is the overrides. So you have based chart, and you can implement for the each environment the overrides of the configuration. So, and how we can manage it? Because of this is the tool set, how we manage, what the flow. The flow is we absolutely shift left DevOps, and our developers teams, they use DevOps its own. So all pipelines or MRs or change management, the commits, promote, and whatever, it's related to the team. So team have able to change application parameters or even Flux configuration with the MRs. We as a SRE team, we can support, assist, or approve the changes for the production, and only for the production, because all other environments they can just promote the application. So this is the really maybe simple. So configuration in the chart, changes configuration with the MRs that's managed by Flux, GitOps, let's say.
Yeah, we got it. Hope Konstantin Denis answered your question. And there is really one more interesting question from Ilya. May you tell us the best? Oh, one more time. May you tell us the best use case scenarios for this approach, for this solution, and furthermore, tell us bad cases scenarios it could help to avoid.
Okay, so first of all, let's say two examples. The right case, because of you even maybe now use, if you use the Kubernetes, you for sure use the controllers because of cloud controllers, not NOS controllers, whatever. In case you use the GitOps, you already at minimum, at least you have 3 or 5 controllers already in your configuration. And one more controller, it's pretty much, for example, Vault operator, secrets management, and whatever. This all about the controller. The platform engineering, it's all about the controllers. So some of the custom controllers is just to extend your daily operation. So you can just write the single small custom controller to make something, for your that best fit for your really current environment. The bad, let's say bad, so no recommended maybe. That's where you are maybe not involving in the Kubernetes world. So your application relate, for example, on a serverless, on a function as a service, or something that your operation is relied to, infrastructure as a code and or just the code itself. So no space to run something custom, and maybe no requirements to run the some stuff. For example, high-load trading, because you have the servers, you have the hardware focusing, and you are requirement about the low latency, and that's why you don't use Kubernetes itself as a maybe middleware that increase your latency. So you work actually like a straightforward application with the hardware. Maybe this is some kind of bad example. Yeah.
Okay, thank you for this, and maybe the last but not least. Konstantin, I have another question from the audience. Do you have a system for approving deployment to production, and how it look like, and how it relates with application controller which you have presented?
Okay, thank you. You mean the system, you mean the flow, how we approve. We have a really not trivial release flow system. So this is the part of the release team, let's say. This is the some kind of CAB, change advisory board and whatever. So this is the some kind of members of this board, and they we have some kind of rules or acceptance to your application become promoted in the current release. For example, we have a tens of the teams, we have 100 of application, and we cannot control each one. So we cannot approve the each one, but there is some kind of flow. So your application should pass the number of tests. You should commit to master. In case you are in a master, so the some kind of QA testing passed, and you are candidate for the current release. Next, the controller come to scene, and there is some kind of automation from the release teams that they ask for the controller to get me the promotion plan. So all kind of candidates for current release in a list. And next, this is some kind of bundle. And this bundle just promote to the prod automatically. And after that, we have some kind of end-to-end test and whatever that we commit the prod promotion. So everything good, okay, we close this release, and that's it. So under the hood, some kind of complex manual and automatic steps. From our point, there is no special approvals, because of all pre-release steps, they approve themselves in natural way because of master, because of test, because of team leader of team actually already approved to push the master and whatever. And all other steps, it's already automated from the stable environment to the production. Okay.
Okay, thank you, Denise. And maybe the last questions, just your thoughts about what's the next, and how can AI impact in this for these approaches, and in general, maybe for DevOps and organization deployments and releases.
I'm not sure I get your. Am I right that you asking? Yeah.
Just about trends. What's the next, and about this topic? So, what
Okay.
will be
Okay.
maybe
Great.
in several years? Maybe some AI tools will just make a significant impact in this
Okay.
approach.
Okay. I guess this trend, the trend for this, especially this topic, it's not the AI itself, but the platform engineering more, because of we have
Mhm.
two trends for now. Let's say AI and platform engineering, and this one uh, related to the platform engineering. Why? Because of um, at the end of this story, we integrated, now we're under the process to integrate all kind of automation with the controllers and whatever with the platform engineering single platform. And this is some kind of approach to manage all this complex solution via single platform for the dev teams. So because of API, because of some kind of plugins integration, you can fully manage it on the abstract level, on the single UI, with the automation with the CRD, Kubernetes resources, and whatever. So, and you can find it in already on all kind of conference, platform engineering conference, KubeCon, and whatever. They really push the API of Kubernetes to the platform engineering stuff, because of trends, because of something we need to change, transform, and whatever for the new one. And the crew is the one of the project that I guess uh, we saw in this year, or maybe they raised on some kind of production. I'm not sure, but anyway, because of big gangs already on the topic. So that's why this is this approach. It's very common approach because of Kubernetes already used controllers. And next we can see the trends of the all cloud providers contribute already and announced this on these topics. That's why it's right time, to play with these trends, to be in this case. Yeah.
Okay, thank you, Denise, one more time for your presentation, for your answers.